Unit 3 Chemistry, Chapter 5, Part 2, Predicting Reactions in Galvanic Cells. So, you have in your data book an electrochemical series. That electrochemical series is very useful to you. It does a couple of things. Firstly, it allows you to cheat slightly when writing some half equations. Unfortunately for you, not the ones that you have to use cohees for, but some simple ones. More importantly, it allows you to predict what's going to react. Because this is organised in order. This up here, fluorine, has the strongest attraction of anything on this list to electrons. It really wants to grab them and become fluoride ions. So it is very readily reduced, making it the strongest oxidant on there. As we go down the list, the oxidants become weaker and weaker and weaker. But their conjugate pairs, the reductants, become stronger. So lithium metal here is the strongest reductant because it really wants to be oxidized. It has no interest in having electrons, it wants to get rid of them. Okay, so everything which is on the left is a possible oxidant, getting weaker as we go down. Everything which is on the right is a possible reductant, getting stronger as we go down. Now we can use that to predict which way a reaction is going to go. So if we think about our Danielle cell again, okay, we've got a zinc and a copper half reaction. Let's look at it. Here's copper and here's zinc. Because this is higher up, we know the copper 2+ ions are stronger oxidants, which means that they are going to be reduced. Okay? And we know we have to have oxidation in one half reaction and reduction in the other. So if these are being reduced, that means that our zinc has to go in the reverse direction. Okay? These double-headed arrows mean that they can go in either direction, but then once you've figured out which way it will go in that context, you write it with a one-way arrow, and you write it the normal way around. So you'd write zinc metal on the left, becoming zinc ions and electrons. Okay? Limitations of this series. Firstly, it's only valid for standard lab conditions. Remember, that's 25 degrees C, 1 atmosphere, or 101.3 kilopascal, same thing, and 1 molar concentrations of the solutions. So if you change the conditions, the reactions might not occur as you predicted them to. It's also not a particularly accurate prediction when the substances are very, very close together on this series. So whilst it's good for prediction, it also doesn't give us any indication of whether it's actually going to happen, so we've got to check it by. We also don't know anything about how fast these reactions are going to go, or anything about what's called the position of equilibrium, which you're going to learn about in the next area of study, and it's worth remembering, because that tells us how far the reaction goes. Yeah, whether it happens almost to completion, or whether we're still left with a lot of our reactants. But let's say we're in SLC, we've got 1 molar solutions, they're a long way apart. We can use the numbers on the electrochemical series to work out the potential difference, which you probably know as the voltage. The further apart they are, the bigger the voltage that we get. Okay? The values that are in there are all how they go when you compare them to what's our standard half cell, which is the H2H+ half cell. Okay? So this one here, which has got a value of 0, everything else is compared to that. If we want to know what happens when we link any two cells together, it's the difference between their E0 values. So for copper, for instance, it's got a value of plus 0.34. If we compare that to our zinc, minus 0.73. The difference between them is 1.1 volts. So our Danielle cell is going to give us a potential difference of 1.1 volt. But remember, it's only going to give us that if it's SLC, and we've got 1 molar solutions of both the copper ions and the zinc ions. Yeah, I know the zinc ions are a product, but they've still got to be there. Yeah, because if they're not there, then we can't complete the circuit through the movement of charged particles. Now, we'll come on to the different types of cells in our next video.